All right, so we're continuing with our exponential and log relations. We're going to be talking about exponential and log forms of equations, okay? So it's important to keep in mind that whenever we are dealing with logs, we want to think about them in terms of exponents, okay? The base of the log is the same base as the exponential. I don't know if y'all noticed that. When we canceled them out, the bases have to be the same, right? Because that's their connection to each other. That's because they are inverse relationships, which we'll learn more about starting tomorrow. The argument of the logarithm is the value that we want the exponential expression to equal. So that's what this underneath is telling you. So the definition of the logarithm is saying that if b and n are positive numbers, okay, and notice that b cannot be 1. So you cannot have a base of 1. Then, therefore, you can take your log and you can make it into an exponential. Notice that the base of the log is going to be the base of your exponential. Okay, this is your argument. N is called your argument. Your argument of your log is now going to become the answer, solution, result of your exponential. And the solution of your log is going to become the power of your exponent. Solution, I just like writing out the whole word solution. SOL for solution. Okay, so they go together. Base stays the same. Argument is now my solution. Solution is now my power. Okay, all right, so what we're going to do is we're going to do the odds together, and then I'm going to let you do the evens. Cool? Okay, so looking at the odds, I want to write this as an exponential form because if I write it as an exponential, I can verify that it's a true statement. Does that make sense? So first thing I'm going to notice is my base. What is my base? 2. Okay. What is my solution? 3. And what's my argument? 8. Does 2 cubed equal 8? Yeah. Okay. Let's do it again. What's my base? 2. What's my solution? What's my argument? 1. Does 2 to the 0 equal 1? Yes, because anything to the 0 power is 1. Okay, let's do it again. What's my base? 16. What's my solution? What is my argument? 2. 16 to the 1/4 is asking, what is the 4th root of 16? So what number times itself 4 times equals 16? 4 times 4, that's only twice, is 16. But 2 times 2 times 2 times 2 equals 16. So that's why 16 to the 1/4 equals 2, because that's what it's asking you. When you have a rational or fractional root, it's asking you to take this power, it's asking you to take the root of it. All right? Okay, I'm going to pause, and I'm going to let you do 2, 4, and 6. All right, let's see if you see the pattern and you are comfortable. All right. All right, number 2. What's my exponential? What is it? 2 to the negative 2 equals 1/4. So going back to algebra 1, when you have a negative power, that means that it belongs in the denominator. So what this is saying is that I have 1 over 2 squared. And what is 2 squared? 4. Is that true? Yeah. So a negative power means that the actual exponent belongs where? The exponent belongs in the denominator. Okay. All right. On 4, what did you get? 3 to the 4th power equals 81. Is that true? Yes. On number 6, what did you get? 8 to the 1/3 equals 2. So what this is saying is the cube root of 8, 2. Does 2 times 2 times 2 equal 8? Yes. So the cube root of 8 is 2. All right. How do we feel about logs to exponential? All right. Doable? All right, we're going to go the other way now. Now we're going to go exponential to log, okay? So again, I'm going to do the odds and you're going to do the evens. So here we go. Log, our base is still going to be our base. What is our base? 2. What is our argument now? Good job. 16 equals 4. Okay? On 9, how do I write this as a log? There we go. 11. Perfect. All right, quickly do 8, 10, and 12. All right, here we go. So 8, what is it? Perfect. 10. Perfect. 12. Perfect. All right, how do we feel about going back and forth between logs and exponentials? Doable? All right. Moving on. So we're going to write the math sentence of the equation. And the purpose of the writing the math sentence is to help you to understand how to solve it. Does that make sense? So first one, we have log base 5, 25, and it wants to know what is the solution. So what this is asking you, so we're going to write the math sentence first. It's saying 5 to what power equals 25? Yes, I'm going to show you how to write an exponential in a second, though. But before writing an exponential, you're asking yourself, 5 to what power equals 25? What is it? 2. 5 to the second power equals 25. So my answer is 2. So as an exponential, what you're saying is 5 to what power equals 25? Does that make sense? We see it? Is it doable? When you solve for a log, like those are given the solution. What if you're not giving your solution? Oh. Yeah. Yeah. We have to step it up a notch. Okay. All right. What is 14 asking me? There we go. 4 to what power equals 64? So the answer is 3. So 4 to what power equals 64? And 4 to the third equals 64. Doable? All right, let's try another one. We're talking about it. What is it asking us here? 4 what power equals negative 16? Does that work? Is there any number? Is 4 to any power going to equal negative 16? It's not, right? So the answer is no solution. It's not going to work. Not a lot, but yeah. If you go back, remember we had one where we had 2 to the negative 1? Well, no. This one? No, we don't have any. Yes. So when you have a negative exponent, that means that the whole exponent actually belongs in the denominator. So 2 to the negative 2 means that I have 1 over 2 squared. And that's why the solution is 1/4. Okay, so this is an example where I had a -2, but notice that my argument was a fraction. Do you see that? Here, my argument is not a fraction. What is my argument? It's a whole, right? A whole integer. And so that's why it is no solution. All right, so here, what is 16 asking me? So what is it? Oh, okay, good job. Okay, what? I'm sorry. On 16? 10 to what power equals 10 to the third? What is the power?
What?
10 to the, I'm about to write an exponential. 10 to the x equals 10 to the third. What is x? 3. Because that's what you have to understand what you're asking yourself. We're writing the words so that you don't have to keep writing the words. We're learning to think about it. You have to think about the math.
Was it infinitely more confusing whenever you did it?
But would you have known right 10 to the x if you didn't know what the words were? No, I wrote that, but did you know that this is what you were supposed to be writing until we wrote the word form? No, you didn't. All right, 17. What am I asking? What am I asking myself? 3 to what power? Hey, real friend, can we all pay attention? Good job. Okay, well, I need a fraction, right? If I'm going to have a fraction as my argument, that tells me that my solution has to be what? Negative. Okay, so, and this is saying 3 to what power equals 1/3? What number will move my 3 to the denominator? A negative, and it will just be a -1. Because 3 to the -1 equals 1/3.
Does it?
It does. Exponent rules. A negative power means it belongs in the denominator. It's been a bad number. That's what my teacher said. That's what my teacher said. Because it's not multiplication. It's a location. It's not, you're not multiplying, you're relocating. That negative is a relocation, not a multiplication. It's not saying 3 times -1, which would make it -3. It's saying 3 to the -1 power. So I'm still doing 3 to the 1 power, but in the denominator instead of in the numerator. So if you saw 3 to the 1, that's just 3, right? Okay. 3 to the -1. Why would it be -3? But that's what I'm telling you. That negative doesn't represent multiplication. It represents a relocation. A negative power is not multiplication. You're not multiplying it by anything. It's telling you that it belongs in the denominator. The reason why they started writing it like that was because of scientific calculators. Not all of them you could write a fraction. And so then they created the exponent rule for it to be a fraction. Okay. All right, so 18 and 19 were meant to be a little challenging, so let's see how it went. So 18 is asking us 9 to what power equals 3? Okay, now, as an exponent, that looks like 9x equals 3. Now, if x is 1, that automatically tells me that I'm over, right? So that tells me that my x has to be less than 1. Does that make sense? Your x has to be less than 1 because otherwise you're going over. Okay? What is the relationship between 9 and 3? Besides being a multiple, what's the other relationship? And 3, okay. So it's the reason why it's a half is because the other relationship is what's the square root of 9? 3, right? So the square root of 9 equals 3. The square root symbol, guys, that's what a half means. Okay? If I'm taking the square root of something, that's a half. That's a half power. If I'm taking the cube root of something, that's a third power. If I'm taking the fourth root of something, that's a fourth power. So let's go back and look here really quick. So remember how we had when we wrote 16 to the fourth, and I told you that that's the same thing as saying the fourth root of 16, and we had 8 to the 1/3, and I told you that's the same thing as saying the cube root of 8. So here, I know that I can get 3 by taking the square root of 9. So therefore, it's going to be 9 to the 1/2. Okay? So 19. Okay? A negative what? Almost. Yes. All right, let's talk about 19. So 19 is saying 16 to what power equals 1/2. Again, it can't be greater than 1. Does that make sense? Because 16 to the 1 is 16. I'm going to be past a half already. So it has to be less than 1. So I know that it has to be less than 1. What is the relationship between 16 and a half? Well, this means that this is in the denominator. It's negative, right? So you're looking for 1. You know it has to be a negative. And what's 16 to 2? 16 to 2, we've already talked about. It's the fourth root. The relationship between 16 and 2 is that 2 is the fourth root of 16. We already said it has to be less than 1, so it has to be 1/4. It's 2 times 2 times 2 times 2. Okay? Fourth root. Again, why is it the fourth root? That's because 2 times 2 times 2 times 2 is what? 16. I have one group of 4 of 2's equals 16. Okay? All right, so that concludes our log and exponent to log. It is a lot about pattern recognition and recognizing the pattern, okay? And you have to be okay with finding and looking at that pattern. On your assignment, so if you go to your assignment, I'm going to open it here, though. Where is it? 2.2c. On your assignment, I put an example here. So it says log base 10, 100. What is this asking? So you're writing out what is the sentence? It's saying 10 raised to what power equals 100. Okay. What is your exponential form? Well, the exponential form would be what? How would I write that as an exponent? 10 to the x equals 100. What is my solution? 2. Okay. That's what you're expected to do on that handout. Okay. Got it? All right. And this is due Monday. It's technically due tomorrow. Yeah. All right. Questions, comments?